Both solar and wind are intermittent sources of energy, even though the long-term average is 200 watts per meter squared. It's not always there. In the daytime, you have the diurnal cycle for the solar energy. And for wind, the utilization, the capacity factor in most wind turbines, only about 20% of the time are they even turning, depending on where they're located. So how do you take these intermittent sources and make them available full-time as for baseload electricity generation? And that's the best utilization for these sources, is to make electricity and available on demand. The major need would be, if you're going to use terrestrial solar, is for some storage technology that can that can absorb excess amounts of electricity when you're generating it and give it back. We don't have that technology. I mean, a few countries like Denmark produces about 20% of their energy with solar, with wind. That's very high penetration level, the highest in the world as a fraction of GDP. And the only reason they can do it is because in their neighbor, Norway, is 100% hydro. And they use pumped storage of hydro. They're on the same electrical grid. So they pump the water up these Norwegian impoundments when they have excess, and they run it down for electricity afterwards. That's not something that's available to most countries in the world. It may not even be available to Norway if global warming takes out their high altitude ice. But it is available now. So there are some technologies for dealing with that. I mean, pumped hydro, maybe it's 1% in the United States. What people are looking at are various. They're looking at large-scale batteries called flow batteries, which are fluid batteries that you move the electrolyte from one side, from the cathode to the anode. At utility scale, we don't really have anything. The next probably the most discussed is compressed air storage, and it's not what most people think it is. Most people think that compressed air storage is you compress the air with electricity from wind or solar, and you pump it into underground cavities. You usually use evacuated salt domes under the earth, and then this high pressure air is blown through some kind of a turbine, and you get the energy. That isn't going to work, because that would work if you wanted to make a refrigerator. It would basically go into cooling the air. It's not a very good source of energy. In fact, that's how refrigerators do work. You compress the air and then you expand it. If you want to get energy out, the air has to be hot, because the energy actually comes from the heat in the air. In a gas turbine, for example, a gas turbine compresses the air in a compressor stage, which is rotating on an axle, and then fuel is added. You heat the fuel in the air mixture. The heat then creates hot, high-pressure air. The hot, high-pressure air then flows through turbine blades, rotors and stators, that rotating and stationary parts. And 2/3 of that energy goes into running the compressor. So compressed air storage is based on, instead of the compressor, you don't have a compressor stage in a gas turbine. You let the underground high-pressure air run the compressor. And you still have to burn something, and normally what's burned is natural gas. So you have a high-efficiency heat engine combined with a storage, with electricity generation by wind and solar. It's not clear that the combination is going to be that efficient. If you look at the efficiency of compressed air simply as a storage device, it's about 60% round-trip efficiency based on the limited number of experiments. I mean, round-trip efficiency is if you take into account the losses in compressing the air and then when you back expanding it. That's not as good as the 85% of pumped storage, but its proponents think that someday that will happen. There's something inherently a problem with it, in that when you compress gas, you normally heat it up, and the heat of compression is normally lost to the walls of the chamber which are not insulated. So that's why you're not getting very good efficiency on compressed air storage. Batteries, Bill Gates has a nice talk where he says if you take all the batteries in the world, it can only store the energy that we use for 10 minutes. I don't know if that's true. It's probably maybe a little bit larger than that. Maybe it's an hour, but you're going to need 24-hour storage if you're going to use solar energy. And the cost of the storage is linearly proportional to the time it takes to store it, because there's a certain number of kilowatt, it costs you a certain amount of money per kilowatt hour, like $400 per kilowatt hour of storage, but that depends on the number of hours. So the larger number of hours that you have to store it, the more it's going to cost. And there's also problems of how many charge-discharge cycles the storage is going to be able to go through. So we need to increase the research on storage. Okay, now the other approach is we have not resolved, we have never really resolved, not in the alternative energy community, the issue of whether it's better to have distributed generation of solar energy. Everybody has a windmill on their roof or a solar panel or a group of buildings in a community, or long-distance transmission from deserts like the Sahara or the Sonora Desert in the U.S., where there are clear advantages to locating solar collectors in cloud-free deserts and locating wind turbines offshore, for example, for that matter, and transmitting it over long distances at low losses. And if you're going to do that, we may need a totally different kind of electrical grid that we have in the United States and the world. Our electrical grids are designed for centralized power plants like coal-fired power plants or nukes, which, as far as the grid is concerned, are the same. They produce a relatively constant level of power output, let's say a gigawatt or a gigawatt is what some people would say. And then you can, that variability is not designed to handle distributed sources, low intensity. We'd have to rebuild the entire grid. A lot of that will depend on computer technology that would be somewhat similar to the internet in a sense, in that you'd have many, many distributed users and many distributed producers, and you'd have to balance or load manage that system. That would be an Apollo program in itself, as would the storage be an Apollo program in itself.